All right. So yesterday, y'all better pay attention. Yesterday, or school yesterday, whatever, we did changes in M and V, and we talked about things getting steeper, flatter, reflected, shifting up, and shifting down. We kind of talked about how, like, I can't shift up and down at the same time. We talked about how we can't be steeper and flatter at the same time. So when we look at changes and we're talking about slope, we can see three different things. We could see a reflection, the steepness could change, and it could shift. All right. So today and when we talked about these, remember the examples that I gave you? Sorry, the examples I gave you were like 2x to negative 3x. Remember, we just look at the number. 3 is steeper. 3 is bigger than 2. That means negative 3x is steeper than 2x. Here, 1/2 x is flatter than 2x. We kind of compared these to other functions. Now, when we do this in function notation, which is what we're doing today, it doesn't have to be. We only compare against the parent function. Okay. Now, first of all, I don't know what happened here. These should all say f of x equals x. So let's go ahead and fix that. I don't know why I put 1. I don't know. I was panicking and hurrying fast because these notes were a hot mess. Okay. So we learned about, when we, on Friday or Thursday, whatever day that was, when we did our activity, we learned about reflections first. Okay. And that was when the slope, when it was positive, it was going uphill, and it was negative, it was going downhill. Okay? So here's how we're going to remember that. We are going to take a bow. Not a bow, not like a JoJo bow. We're going to take a bow. Because and I don't know how to show this to the online folks, but if I bow, so like if I go, I bow, right? So when I actually bow, I'm doing the start of a vertical reflection, because a vertical reflection goes, okay, I don't know how to make this happen. Vertical reflection goes like that. So it goes from here and it flips over. Let me show you what a vertical reflection looks like on the calculator, and I'm going to show you. Hang on a second. It is so loud next door. What is happening? Oh, okay, now I feel bad. Okay, so this is what a reflection looks like. You see how it was up here where the blue is, and then it reflected over. So it's like we're taking a bow, we're bending at the middle, okay? So that's how we're going to remember physically, is by taking a bow. Okay, now, this is what it looks like in function notation. It looks like that. Write it down, and then we're going to talk a little bit about what it means, because it's definitely unusual looking. We've never seen anything like that before. Okay, so let's say I had f of x equals 3. Actually, let's go even simpler than this. Let's say I have y equals 3, and then I have like k equals negative y. How could I figure out what k was equal to? Okay, I could substitute 3 for y, because if these are both y, then that means anywhere I see a y, I can stick a 3, right? So that would mean k equals negative 3. Are y'all okay with that? Okay. No, because I'm plugging it into negative y. Yeah. So now what if I had, what would I have? Y equals, f of x equals x. Okay. G of x equals negative f of x. Okay, so we said earlier that when these are the same, we can substitute. Remember this, let's take this back a step further even. What if f of x is 3? Yeah, so could I plug, anywhere I see f of x, could I plug in a 3? And then I would have g of x equals negative 3. Well, again, so what we're going to be doing is we're going to be doing that with variables. So we have f of x equals x. That's my parent function. And then I have g of x equals negative f of x. Well, anywhere I see f of x, I can stick x, right? Which means I can say that it equals negative x. Why does this matter? Because we're about to be sticking stuff in the calculator. Okay? So we're going to try and make this as calculator friendly as possible. So this is what a vertical reflection looks like. And that's what we call it. Remember before we said it was just this is a vertical reflection because we have vertical transformations and we have horizontal transformations. Okay? So a vertical reflection looks like negative f of x. So how would I write that in my calculator? Well, I would say y1 equals negative x, bless you. So all I do is drop the f to put it in my calculator, negative x. So I go to my calculator and I put in negative x for y1, and then I'm going to look at the table. Because what we want to do is we want to be able to plot another line so we can see what it looks like. Now, these transformations are really hard to see when you're looking at lines. I know this is like a super boring lesson, and I'm really sorry about that. I wish I could make it more interesting. I think I'm about to try, but we'll find out what happens, okay? So I'm going to plot these points. So I have a point at negative 2, 2, point at negative 1, 1, 0, 0, 1, negative 1, 2, negative 2. Okay? And then I lost my ruler. Like, how does this happen? Okay, here, I found my ruler. That's how this happens, okay? And then I'm going to connect these points. Okay. I know this is like the tiniest graph, but... And there is my new line. Does that look reflected? How many of you are like, I guess so? Yeah, okay. And that's part of the problem with lines. When we start doing quadratic functions, it'll start to be a whole lot more obvious because you see how it's so much easier to see that this is reflected? All I did was take x squared and make it negative x squared, and that's all I did. Okay? So when we start doing this, so we're going to do this now in linear functions. We're going to come back to it again in quadratic functions. This is going to make a whole lot more sense in quadratic functions because first of all, you'll have time to stew on it, like it'll have time to sit in your brain and grow like a bomb. And it'll have time, it'll just make more sense. Okay? So what this means, how are we going to describe this? I would say this is flipped down. Okay, that's how I would describe that. Using words, I would say it's a vertical reflection, but what do I see? I see that it flipped down. Okay? All right, so that's the reflection, the vertical reflection. Let's talk about the vertical stretch. Here's how we're going to remember the vertical stretch. Mike TV. Okay? I'm going to show this clip, and I'm hoping that I don't get like, that YouTube doesn't go nuts about it, but whatever. So this is Mike TV. Have y'all ever seen Charlie and the Chocolate Factory? Yeah. Okay, so in Charlie and the Chocolate Factory, Mike TV, so has anybody not seen Charlie and the Chocolate Factory? Doesn't matter, one of them. Has anybody not seen it? Awesome. Okay, so Mike TV, he's the kid that plays video games and watches TV all the time. He's kind of a butthole. I'm sorry, I probably shouldn't have said that, but whatever. And he's kind of a jerk. And they have the giant chocolate bar, and they're going to transport it across the room so the kids can reach it and grab it out of their TV. And he's like, okay, I'm about that TV life. So he jumps in the machine and gets transported across the room, and he comes out, and he's like this big. And what happens? Who remembers what happens? His dad's like, you got to fix him. And he's like, well, I can't send him back through. There is no back through. So they put him in a taffy puller, right? And this is what Mike TV looks like when he comes out. That's what Mike looks like. So what happened to Mike? He got stretched vertically, right? And when he got stretched vertically, what happened to him? He got real what? Real skinny. He got real narrow. He got real narrow. So Mike TV got real narrow. Okay, so that's how we're going to remember. We're going to remember. So first of all, the hand gesture for a vertical stretch is like this. It's like, you know like Grandpa Shark? He goes like that. Grandpa Shark, right? Except Grandpa Shark's just opening his mouth. That's what it looks like. It's like we're going like that. Now it's not like at an angle. It's not sideways. It's like vertical. Okay? Y'all do that gesture. Should be like this. Go for it. Excellent. That is a vertical stretch. Okay? Here's what it looks like in math. AF of x, where x is greater than 1. Now, notice I didn't say the absolute value of x. I'm sorry, A. Sorry, A is greater than 1. My bad. A is greater than 1. I didn't say the absolute value of A because we already dealt with the negative. If we see a negative, that means it's reflected. Once I decide that it's reflected, I don't care about that negative anymore. I already dealt with that. Okay? I'm just looking at the number of A. Okay? So, what if I gave you that, 3f of x? How would I put that in my calculator? Y equals 3x. Okay, so let's put that in our calculator. Let's plot some points. Let's see what we can see. 3x. And I'm not going to plot. I'm just going to plot a few. -2, -6, -1, -3. Okay. Y equals 3x. Okay. Did you put y equals 3x? Y'all are looking at me with stinky face. Is this what y'all got? I put y, so in y1, I put 3x. Then I hit second table and I pulled these first 5 points off the thing, and then I just jumped out the way and let the magic happen. Are you just angry at the board, or are you having trouble seeing? Okay, all right, good. That makes me feel better because I can't tell if you're like, I don't understand any of this, but this makes me feel better. I feel like you probably, here, let me do this number. There we go. That better? There we go. Yeah. Okay. All right, so these are the points that I plotted. So is this steeper? Is it, now, when I say more narrow, what I'm saying is, do you see how here and here, how at 10, instead of being all the way out here at 10, it's only over here at 3, or at like 3 1/3. And this one is closer, so if it looks almost like I squished it together, or like I stretched it, like it's narrower. Okay? So it's narrower. So what I would say for this one, and this is what you can describe it, it is 3 times steeper. It's 3 times steeper. So this is 3 times steeper than the parent function. That means it's moving up faster. What do we think? Do we hate it? It's okay. We're going to be all right. We're going to get through this together, you guys. Okay. Now, when we had a flatter graph before, our slope was was between 0 and 1 as it got flatter, right? It got closer to 0. Okay, same thing here. Now, here's how we're going to remember this. We're going to remember this with a hydraulic press of a tennis ball. HYDRAULIC press. Now notice, press, compression. Okay, so that should be easy for you to remember because it's a hydraulic press. Okay, so let me show you a video of a hydraulic press. Okay, so here is the tennis ball. Now, we are watching what happens. Yes, we are watching what happens to the actual ball. Okay, so we're not. Okay, so you notice how it goes from here to here. It's about that wide. Let's watch what happens to the shape of it. And this video is loud, and I'm sorry about that. Oh, I turned the volume down. Now watch. We're watching. And then right about here, look at that. This thing was going from here to here, and now look how much wider it is. So when we compress something vertically, it squishes out the sides. right? You squish it, you compress it, and it all squirts out the sides. It gets wider, okay? So that's what happened to this. So when we think about the hydraulic press, no, seriously, come here. Come on, show me love. We're looking at this is getting wider, okay? So when we look at the hydraulic press, it gets wider, okay? I know, I didn't have enough room for the tennis ball. I had to write real small. Sorry about that. So here's what that looks like. It also looks like A f of x, but this time A is less than 1. Now remember, I don't care about negative. The negative means something else. I'm just talking about just the absolute value of that number. Okay? Are we okay with that? So let me give you something you can try. So how about 1/3 f of x? What would I put in my calculator? 1/3 x. Y equals 1/3 x. Now, on this one, I would not use the points that are like, I would not use, what are those things called? I wouldn't use the ones that have fractions for y. So, like, let me show you. So, like, I wouldn't use, like, -2 and 2/3, like y, right? I would use, like, -6, -2, the whole number ones, -3, -1. So -6, -2, -3, -1. Let's see what else we got. 0, 0. 3, 1. And I'm going to assume we got 6, 2 also. 6, 2. So those are the kind of points that I would plot and then connect them. Does this look flatter? Yeah, it's definitely flatter. Okay? It is 1/3 as steep as the parent function. Okay? So it's 1/3 as steep as the parent function. Okay? Huh? Is what? Yeah, that's the reason why, like I said, what I did was I didn't do any of the fraction numbers. I did whole numbers. So I did 6, 2 and 3, 1 because I don't want to be plotting fractions. I'm not here for that. Okay? All right. So when we think about these notes, okay, when we think about this, we could have a reflection, right? I could have steeper or flatter, okay? But am I going to see them both happening at the same time? No. I could also have a shift up or a shift down, but I'm not going to see them happening at the same time. Okay, so let's talk about shifts up and down. Now, I'm sorry, I don't have anything cute. I don't have a cute video for the translations. I had a hand gesture, but then somebody took it to a place they shouldn't have, and now I can't do it. So I'm going to have to show you a different hand gesture that I thought of on the fly because this is why we can't have nice things. Okay, so here's how I think about shifting up. I think about climbing up a ladder. Okay? So I'm thinking about climbing up a ladder. So I'm going up, 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 right? So when I climb up, I go up one rung, up another, up another, up another, up another. So I'm climbing up a ladder. So that's actually the hand gesture that we're going to use. We're going to be going up or down, but we're not changing our slope, right? We're just going up or down. So up or down. We're not changing the slope. Actually, up. So for shifting up, we're going up. If we're shifting down, we're going down. Okay? So here's what that looks like. F of x plus d. Okay, and d is kind of like our y-intercept in our own. Okay? So let's say I had f of x plus 4. What would I put in the calculator? You guys agree? He said x plus 4. Do y'all agree? Because remember, all I do is just drop the f. Why do I make it complicated? Yeah, I don't know why they got to make things so complicated. Okay, so let me see what points I got. I got a point at -2, 2, a point at -1, 3, point at 0, 4, point at 1, 5, and a point at 2, 6. Okay? When I connect those points up, you can see that it just shifted up. So it just went, the y-intercept just went from here, whoop, it went up 4. So it's shifted up 4. Okay? Okay? And if you actually count, it's 1, 2, 3, 4. It actually shifted up 4 spaces. Okay? I know the graph is tiny, but at least there's a graph. There wasn't one earlier. It was a mess. So if shifting up is climbing up a ladder, then what is shifting down? Climbing down a ladder. Yeah. And I had somebody, okay, interesting, somebody said, well, what about riding an elevator? I'm like, yeah, you could do that. And they're like, what about riding an escalator? No. Because an escalator goes like that. It doesn't go straight up or straight down. It goes at an angle. So an escalator would be more like slope. This is a shift goes up or down. That's why I'm saying a ladder. I wouldn't even say climbing stairs. I'm saying a ladder because stairs are at an angle too, right? Upstairs, so going up a ladder, going up an elevator, that would all be fine, but not stairs, not an escalator because they go at an angle. Okay? So climbing down a ladder, what do we think that would be? F of x minus d. There you go. So it will be f of x minus 4, which we would put in as y1 equals x minus 4. What do you think is going to happen to it? What's it going to do? It's going to go down how many? Down 4. So let's see if our hypothesis is correct. Okay, so 2, negative 6. 1, negative 1, negative 5, 0, negative 4, 1, negative 3, 2, negative 2. And that looks shifted down 4 to me. Okay? So this one is up, and this one went down. And that's when, like, using a colored pen, not that I want you to use colored pens, but that's when, if you can do it, honestly, I wouldn't be using a color. I didn't use a colored pen for the first 2 class periods because I'm terrible at graphing. But, you know. So what do we think about this? Again, I don't expect you to love it, but do you kind of somewhat, maybe a little bit sort of understand it? Okay, so what I want to do is I want to summarize what we found here, but I want to summarize it right here. Okay, so today we learned about 2 different parts of these functions. We learned about A and D. Now, we will have to write about B and C, so I'm going to kind of draw these arrows so we can talk about them like kind of off to the side so we can get to a B and C tomorrow. Okay, so there were 5 changes, but only 3 that we could see at a time. Okay, so one that we could see, definitely, was a vertical reflection. Okay, a vertical reflection was negative f of x, and it had A is negative. Okay, so a vertical reflection looks like negative f of x, and the reason it's a change in A is because A is negative. Okay? The second thing that we could see is one of 2 possibilities. Okay? So we could see a vertical stretch, and I think I called it a stretch. Sometimes they call it an expansion, but they're real inconsistent about it. They're more consistently they call it a stretch. So a vertical stretch is where is A f of x when x is bigger than 1. Okay, so that's one that we could see. So I'm going to highlight these. Again, you don't have to, but or at least maybe underline them. So that's one that we could see. Or we could see a vertical compress. And that's also A f of x where x is less than 1. And again, remember, we're not worrying about the sign. We've already dealt with the sign up here in this vertical reflection. If we see a sign change, that means we have a reflection. We're just looking at the number at this point. Okay? So those are the the three possible things that we could see changing A, but we'll only see two of them because we can't see a stretch and compress at the same time. Are we okay with that part? Okay. Now over here on this side, the third thing that we could see a vertical shift up, which is f of x plus d. Okay, so we could see a vertical shift up, which is f of x plus d, or we could see a vertical shift down, which is f of x minus d. Okay, so there are three, in a function, we could see three vertical shifts happening at the same time. If we can see three vertical shifts happening at the same time, how many horizontal shifts do you think we could see happening at the same time? 3. And we're going to learn about them tomorrow. Okay? Tonight's homework is pretty straightforward. I don't think you're going to have a ton of problems with it. Bye, Internet.